In this video, we are hopefully going to wrap up the word ranking scenario program. And what we're going to start by doing is creating this frequency dictionary, which basically for each word in the text, it creates a dictionary where like the unique word, that's the key, and the value is the number of times that word repeats. After doing that, we're going to create a ranked dictionary, like a printed ranked dictionary that's going to allow us essentially to print any amount of the top words. So maybe we can take the number of words that we want to print as one of the parameters there, which is going to basically allow us to not only print the top 100, print the top 10, 20, however many we want. So let's get started with the frequency dictionary. Now there's a very easy way to do this function. However, I think it might have a little bit of too much processing time. So let me show you what I mean. So you basically have a frequency dictionary, and that's a dictionary, and you can go for each word, for word in words, frequency dictionary of that word is basically equal to words dot count that word. Now, if you think of a word that repeats, 1,000 times, like that, or Harry, for instance, then this is going to be, the key value pair is going to be written 1,000 times. That might actually slow us down. So I'm going to practically test this to see how fast it returns. Return frequency dictionary. And if it's done reasonably quickly, then I'm going to stick with this algorithm. Alternatively, if it doesn't do it quickly, then I'm going to come up with a list of unique words. That's pretty cool. So right now, we can try to print dictionary. So word list is going to be fed into this function. Let's take a little bit of time. Now, this was always going to take a bit of time, but this is a bit much. So perhaps I can just create something like this. Unique words, and that could be a list for word in words if word in words if word not in unique words but append word, and then this is going to basically create that list first of unique words, and then it's going to basically populate the dictionary. This could be significantly quicker. So that's basically every unique word and a number of times it repeats. And as you can see, that avoiding adding the same word again and again and again and again has basically made this process a lot faster. So right now, we are ready to proceed with what is very, very close to the final step. Actually, it is the final step. So I want to implement this printing of the ranked dictionary before I implement the filter that takes out the common words. And the reason for that is I want to see the results before and after the common words has been included. So how to print a ranked dictionary? Well, the function is going to need to take in a dictionary, and it's also going to take a count of words. Like we can say min or maybe count, and we can give that a default value, say 20. So first of all, since dictionaries are not indexed, they cannot really be sorted, but you can use the sorted method on a dictionary, and that's going to basically give you a list. So you can actually have something like a ranked list, and that can use sorted. So you start with an iterable, and that's going to be dictionary, and then you have a key, which is going to be basically the key of the dictionary. So it's going to be it's going to be dictionary.get. This is going to be the value, dictionary.get. And we're going to go highest first, not lowest first. So that's going to be reverse equals true. Now that we have a ranked list, we can basically say for I in range, and that's going to be count. or 0, count. I kind of prefer doing 0, count. It's, I don't know, reminds me of a more traditional for loop, 0, count. So this, here we can basically print the key and value of the dictionary and basically say how many times each repeats. So probably can do this in one print statement. Hopefully it's going to look neat. So the key can be ranked list I, and then we can say repeats, and then we can put the value, which is basically dictionary of the key, and not the prettiest line of code, but it will do times. So that really ought to do it. So if we basically just use the print ranked list here, it's going to print the top 20 words. We can change the count to 100, but give us a second. Print ranked dictionary. Yeah, let's try this out. Okay, the to and of Harry. So you see how this is not that informative. The to and of. Like, that's not what a book is about. So I wanted you to see those results before we go around and start removing these unique words. We can also, though, inside this A, we can decide to use other options. U for uppercase, or maybe we can basically turn that into a T for title case. I hate to do this to you guys. I'm actually going to change this to T because I think T is more appropriate. So let's see if we just rank the title case words. Harry, I, he. You see, still there is I, he, the, it, they, and really, if we got rid of those words, we would get closer to the gist of what the book is about, which is exactly why that filter number 5 exists. Now, where can we filter out the common words? Personally, I would do it right after the word list, right? So, in effect, I would basically have something like this, unique words, or, yeah, I already used unique words. I would call them uniques, just for the fun of it. Uniques equals to, and we're going to come up with a function name for this, something like strip common words from word list. So I need to basically create a function that does that, def. Now this is going to need to open that text file, so let's do that. Basically, I can create common words is equal to open, that will be the 1,000 words of txt, 1,000 words txt, is that pretty sure. I'm going to open it for reading only, and then what I'm going to do is I'm going to read it. Common words equals to common words dot read. Now that I've read them, now I can basically iterate through the word list and remove all the common words. So, the question really is, do I want to create a new list for the unique words? And I'm going to do that. I'm going to basically create a new list for unique words. So I'm going to say basically for word, and I'm going to call this words because it's a nicer sort of parameter than word list. So for word in words, if word not in uniques dot append word. It's very much the same thing that I did in the frequency dictionary, sort of the same mechanism. So we have this list of uniques here, and basically that's what we can return. Return uniques. And finally, with all this, return uniques. That needs to be indented one more time. And then put back here. Yep. And who knows? This could work. So we're going to need to use uniques as the input to the frequency dictionary. And I have a feeling it'll probably work faster. There you go. Print ranked words. Harry repeats 1 times. Okay, we made a mistake. The mistake was that these uniques were misused. I really should have said common words there. So if the word is not in the common words, then we can append it to the unique. So the same word can repeat multiple times, and hopefully, there you have it. Harry 1213, he, capitalized he. So maybe if word dot lower, not in unique words. Ha! Harry, Hagrid, Hermione, Professor Snape, Dumbledore, Dudley. Those are all the main characters in Harry Potter, listed for you right here, found by an algorithm. Now, I only printed 20 of them, and remember the task set 100, so we can basically set the 100 as a parameter, and there you go. Those are the top 100 words in the entire book of Harry Potter. Now, finally, looking back at everything we had done, I would strongly, because it takes time, I generally don't do it on the video, but for a function like this function is going to need the doc string. The doc string is going to describe each three of these cases and say what the function is going to return. And the function for printing the words, actually, print ranked dictionary, given that this count is there, should probably include a little bit of the elaboration and a doc string of what there is to do. But you can do that on your own. The main thing is that we basically put together so many of the concepts that we've covered in the course into one program. We've put together lists, strings, dictionaries, file operations, and methods to do with string lists and dictionaries. So finally, we have done something that I really consider substantial and useful, and this is an improvement on some libraries that Python already has in natural language processing. So this frequency dictionary is something that's already in NLTK, but what we've done is essentially improved on a very popular Python tool.